Hello everyone. In this video, we will cover various topics related to the Cartesian plane. We'll learn how to locate points, draw lines and shapes, and explore the Pythagorean theorem. Additionally, we'll see how to calculate the area of different figures in the Cartesian plane. Let's begin. The Cartesian plane is a coordinate system with two axes. The x-axis is the horizontal line, and the y-axis is the vertical line. Each axis has both positive and negative values. For example, the point 2, 2 is located at 2 on the x-axis and 2 on the y-axis. The origin is at the center of the plane, represented by the point 0, 0. The Cartesian plane has various uses, including locating points, drawing shapes, calculating distances, and graphing functions. A point on the Cartesian plane is written in parentheses and consists of two values. The first value corresponds to the x-axis, and the second value corresponds to the y-axis. To locate the point 1, 2, first find the number 1 on the x-axis, then find the number 2 on the y-axis. The point is where these two values meet. To locate the point -2, -1, first find -2 on the x-axis, then find -1 on the y-axis. The point is located at their intersection. To locate the point -1, -5, first find -1 on the x-axis, then find -5 on the y-axis. Finally, to locate the point 3, -2, first find 3 on the x-axis, then find -2 on the y-axis. To draw the line that passes through the points 1, 2, and 2, 4, first we locate the point 1, 2, then we locate the point 2, 4. We also plot the point 4, 6 on the plane. Now we draw a straight line connecting the points 1, 2, and 2, 4. If we look at the graph, we can see the line does not pass through 4, 6. Instead, it passes through 3, 6. To plot the square with a side length of 4 and center at 0, 0, we note that the x values must range from -2 to 2 so that the side length measures 4. Similarly, the y values must range from -2 to 2. Thus, the square with a side length of 4 and center at 0, 0 will be positioned as follows. Now, to draw a square with a side length of 3, such that 0, 0 is a vertex of the square, we can position the square in 4 different directions. We will choose to draw the square in the upper right quadrant of the Cartesian plane. First, we plot the point 3, 0, so that the first side of the square has a length of 3. Next, we plot the point 3, 3 to ensure the second side of the square has a length of 3. Finally, we plot the point 0, 3 so that the remaining two sides also have a length of 3. Now we draw each side of the square. To plot the triangle that passes through the points -1, -1, 1, -1, and 0, 5, we first locate the point -1, -1. Next, we plot the point 1, -1, and finally we plot the point 0, 5. Now, we draw the lines connecting these points to complete the triangle. In the Cartesian plane, we can move from one point to another by going up, down, to the right, or to the left. To move one unit up, we add 1 to the value of the y-axis. To move one unit down, we subtract 1 from the value of the y-axis. To move one unit to the right, we add 1 to the value of the x-axis. To move one unit to the left, we subtract 1 from the value of the x-axis. Now let's look at two examples using distances to locate points. To locate the point that is 8 units above the point, -1, -4, we just need to add 8 to the y value. -4 plus 8 is 4, so the point we're looking for is -1, 4. To locate the point that is 5 units to the left of 1, -1, we just need to subtract 5 from the x value. 1 minus 5 is -4, so the point we're looking for is -4, -1. Now, let's see how to calculate distances between points that lie on the same axis. The distance between 0, 3 and 0, 1 is simply 3 minus 1, or 2, because both points are on the y-axis. Since 1, 4 and negative 2, 4 have the same value on the y-axis, the distance between these 2 points is 1 minus negative 2, which is equal to 3. In the last exercise, 6, 5 and 6, negative 1 have the same value on the y-axis, so the distance between these 2 points is 5 minus negative 1, which is equal to 6. The Pythagorean theorem is used in right-angled triangles, meaning triangles with a 90-degree angle. The hypotenuse is the longest side of a right-angled triangle. The Pythagorean theorem states that the length of the hypotenuse is equal to the square root of the sum of the squares of the other two sides. For example, in a right-angled triangle with sides 6 and 8, the hypotenuse is equal to the square root of 6 squared plus 8 squared, which is the square root of 100, which equals 10. Now, let's look at an example. To calculate the distance between the point 1, 1 and 5, 4, we can plot the point 5, 1 to create a right-angled triangle. We can see that the sides of the right-angled triangle are 3 and 4. Then, using the Pythagorean theorem, the hypotenuse is equal to the square root of 3 squared plus 4 squared, which is equal to the square root of 25. That is equal to 5. To calculate the distance between 2 points x1, y1 and x2, y2, we can use the formula square root of x1 minus x2 squared plus y1 minus y2 squared. This formula works because x1 minus x2 and y1 minus y2 represent the lengths of the sides of a right-angled triangle, and the distance we want to calculate represents the hypotenuse. Note that we can use either x1 minus x2 or x2 minus x1, because squaring both of them results in the same value. Let's look at some examples. To find the distance between 1, negative 2 and 5, 1, we first need to calculate x1 minus x2 and y1 minus y2. The difference between x1 and x2 is 4, and the difference between y1 and y2 is 3. So the distance between 1, negative 2 and 5, 1 is the square root of 3 squared plus 4 squared, which equals 5. To find the distance, there is no need to plot the points. To find the distance between negative 10, 5 and negative 2, 11, the difference between x1 and x2 is 8, and the difference between y1 and y2 is 6. The distance between negative 10, 5 and negative 2, 11 is the square root of 8 squared plus 6 squared, which is the square root of 100, that is equal to 10. To find the distance between 4, 1 and negative 2, 4, the difference between x1 and x2 is 6, and the difference between y1 and y2 is 3. The distance between 4, 1 and 2, 4 is the square root of 3 squared plus 6 squared, which is the square root of 45. Now, let's see how to calculate the area of different shapes on the coordinate plane. The formula for the area of a rectangle is base times height. For example, in a rectangle with a base of 5 and a height of 10, its area is 10 times 5, or 50. Now let's see some examples. In the first example, we first plot the points 0, 0, 0, 5, 6, 5, and 6, 0. Now we draw the lines that form the rectangle. We can see that the base of the rectangle is 6, and its height is 5, so the area of the rectangle is 6 times 5, or 30. In the second example, we first plot the points 3, 2, 3, 5, negative 2, 5, and negative 2, 2. Now we draw the lines that form the rectangle. We can see that the base of the rectangle is 3 minus negative 2, or 5, and its height is 5 minus 2, or 3. Using the formula, the area of the rectangle is 5 times 3, which is 15. The formula for the area of a parallelogram is base times height. The base is the same as in a rectangle, but the height is the distance between the top vertex of the parallelogram and the bottom side. For example, in this parallelogram with a base of 8 and a height of 4, the area is 4 times 8, or 32. Let's see an example. First, we locate the points that form the parallelogram. These are 1, 1, 5, 1, 7, 5, and 3, 5. Now we draw the sides of the parallelogram. The base is equal to 5 minus 1, or 4. The height of the parallelogram is the difference between the y values. In this case, the height is equal to 5 minus 1, or 4. The area of the parallelogram is equal to base times height, that is 4 times 4, or 16. The area of a triangle is equal to base times height divided by 2. Let's see some examples. First, we locate the points. -1, -1, -5, -1, and -3, -7. Now, we draw the sides of the triangle. The base of the triangle is the difference between the x values. That is -1 minus -5, or 4. The height is the difference between the y values. So the height is -1 minus -7, or 6. The area of the triangle is base times height divided by 2, or 6 times 4 divided by 2, which equals 12. In the second example, first we locate the points 5, -2, 5, -6, and 2, -3. Now we draw the sides of the triangle. We will use this side as the base of the triangle. The base of the triangle is 6 minus 2, or 4. Since the base of the triangle is parallel to the x-axis in this case, the height is the difference between the x values. So the height is 5 minus 2, or 3. The area of the triangle is base times height divided by 2, or 4 times 3 divided by 2, which equals 6.